Thank you very much. So I'm Steve Teig, the Chief Technology Officer of Xperi, and I'll give a fuller introduction to our eminent panelists in just a second here. But as a way of just getting the game started, well, I guess we've lost our slide. There we are, thank you. So this session is called How Does the Enterprise Respond to the Rise of AI and Edge Computing? And to set the stage for what this conversation is going to be about, let me talk a little bit about what we mean by edge as distinguished from cloud. You know, if you look back at the history of computing, it used to be that the only way we could build computers in the 50s and 60s was to have a big room full of computing device, and that was it. We wanted to push computing closer to where humans were, we just didn't know how to do it. So then you end up with mini computers in the 70s, a step in a good direction. You end up with PCs in the 80s, better. You end up with smartphones, better still. We find ourselves in a situation now where the prospect of being able to put computing right near where we actually are exists, to put things right next to sensors and other devices that are in our homes and in our businesses. At the same time, we have the data monopolies, the Googles, the Facebooks, the Microsofts, who are building these enormous data centers with millions of computers, aggregating all of the world's data, and who have the business agenda of aggregating all the world's data. You might think that would create an unhealthy tension between that cloud, where all those data centers are, and the stuff that isn't the cloud, which I'm referring to as the edge in the context of this discussion. But in fact, we think, the three of us think, this is a huge opportunity, that you can have as much computing as the context of the gadget needs. So next to a sensor, it would be nice to have enough computing to be able to detect a person, an animal, a passing car. If within a car you have multiple sensors, it would be nice to have something that can aggregate the information for multiple sensors and be sort of the next level of the edge, being able to integrate what it learns from there. At the next level from that, it would be great to have a gadget still at the edge that is looking at a collection of cars and their information and learning about traffic. And at the top of the heap, you end up with the cloud, which has access to all world information, has access to Wikipedia and so on. So there's a great opportunity for us going forward to make use of computation at all levels of abstraction, all the way from the cloud, these big data centers, and all the way down to endpoint devices like sensors and everything in between. And I hope that sets the context for what it is we're going to be talking about today. So with that, let me introduce my eminent panelists. So first, Neal Oman here is the VP of HERE Research. He leads a team of more than 75 folks around the world where they investigate and prototype the latest advances in machine learning, NLP, augmented reality, prescriptive analytics, computational geometry, and other geospatial-related technologies. He's focused primarily on applications for large-scale entity extraction from big data for digital map-making, indoor and outdoor navigation, and location intelligence. Neal brings 25-plus years of experience with large enterprise information systems and software engineering projects, with the most recent 15 focused on applied machine learning and advanced analytics. Neal holds master's degrees in both applied mathematics and aerospace engineering, both from the University of Washington. And our second contestant, Irina Farooq.
Contestant?
You didn't know you were on a game show, did you?
Yeah, exactly. We've become friends already, and you're.
I'm just joking. Irina is the Chief Product Officer for Kinetica and has over a decade of product management experience across a variety of sectors, including enterprise software, networking, hardware, IoT, SaaS, and cloud. Irina was previously at Riverbed Technologies, where she held a variety of leadership roles, including Vice President of Products and Strategy for the service provider business and Vice President of Product Management for Steelhead, which is Riverbed's flagship product. Irina started her career as a software engineer and product manager in Oracle, but before that got a BS in mathematics and BS in computer science from MIT, an MBA from the Stanford Graduate School of Business, and a master's in environment and resources from Stanford University. So a pretty impressive panel. And just briefly, I'm Steve Teig. I'm the CTO of Xperi. Xperi is a leader in imaging and audio technologies, providing such brands as DTS and HD Radio. I'm responsible for corporate vision and strategy there, leading advanced research with an emphasis on machine learning at the edge. I've worked on and off on machine learning for the last 30 years in a variety of disciplines. I've been the CTO of 7 different companies spanning software, biotechnology, and semiconductors. I hold more than 330 patents and have both a world technology Technology Award and an Edison Award. And my BSc is in Electrical Engineering and Computer Science from Princeton. All right, enough of that stuff. Well, let's get into it. So let's first talk about data at the edge and how to deal with that. So with the flood of data arriving at sensors like cameras and microphones, how can one transform that data into inferences and comprehension? And where is that processing usually done? Irina, you want to take a whack at this?
Well, I think a lot of it depends, right? And it all depends on application and what the needs of your application are. Edge in its basic form is a part of a distributed system. And as you're building an application, you have to think about what are the roles of the different nodes in the network and what needs to be done at each part of the node. So, typically the things you would handle at the edge are things that require low latency, where you can't afford a round trip to the cloud. For example, if a car is trying to navigate an intersection, it can't afford to send the data to the cloud and wait for a response to make the next decision. There's another set of cases where it's just not practical to send the amount of data to the cloud. For example, if you talk about HD cameras and using them for theft detection, you can't pipe HD video, even with 5G, for that matter, all the way to the cloud to be able to make an inference. There are also areas where it's for privacy or security reasons. You'd want to keep the data at the edge. I think it's important to note, and I think it was in your introduction, that the edge doesn't mean necessarily a sensor. It could be, but it could also be an intermediate computing device that aggregates information from a set of sensors to help provide the decision. Mm-hmm. And this becomes a platform for you to deploy the latest machine learning models and algorithms and policies, for that matter, in a more kind of old-fashioned sense, to be able to take action at the edge.
Do you want to add anything to that, Neal?
So, I think she hit almost all the points. I think one thing for sure is maybe the privacy and also the data pipeline question is when you have these extremely high fidelity sensors at the edge in the device, multiple sensors, a lot of the time, just the efficacy of bringing the data for latency purposes or just volume purposes is kind of prohibitive, right? So what you'd like to have is the consumption of that data from an inference standpoint or from a decision-making standpoint as much as possible out there at the edge.
So following on that, as we look at the issues of power consumption and of privacy and of security, things people talk about in the context of the edge, can you comment on the trade-offs around that, and do the answers to what to do about those differ industry by industry?
So from my perspective, I think the answer is absolutely different. And I think they don't just differ from industry to industry, they differ from application to application, again, as Irina said, right? That there are times when so we'll just take the consumer, a consumer taking pictures. We'll use a vehicle, right? A consumer vehicle taking photographs and doing inference at the edge. Those photographs contain faces, they contain license plates, they contain various kinds of information that more and more are becoming highly sensitive information. And who nobody's really super interested in having that wind up in the cloud somewhere, right? So they would like to see at least it partially processed before it comes off of the device. So where it's at the edge, totally controllable, license plates are blurred, faces are blurred, other kinds of identifying information removed, and maybe even inference done to extract signs or whatever and location information, and then it goes to the cloud, right? In a much reduced form. So it changes. So that's I'll say consumer-based, crowdsourced data type application. And other kinds of industrial applications, maybe you do want the whole picture, right? I want all the pieces of that picture because my inference is very multifaceted. I have lots of things I want to see in that picture, so I'm going to take the whole picture back to my industrial cloud.
It makes sense. So given that, Irina, can you comment on the different kinds of architectures that one needs to meet these very different kinds of applications that Neal's talking about?
Well, the reality is, when people say edge, everybody means a different thing. It used to be like the cloud. Everybody meant like to the cloud, that Microsoft commercial. What does it mean, right? And so the edge is also, in some cases, as Neal was mentioning, it could be an autonomous vehicle, right? That may have an NVIDIA drive architecture within it and is really kind of computer running within it. The edge could be a server in a manufacturing facility. And the edge could be a part of the cloud edge within a network provider's, a service provider's infrastructure. And so the level, it depends on the application. In some cases, you want to make your end sensors really, really smart. In some cases, you want to locally aggregate the data at the first edge, and then you want to propagate that decision-making through the system. And so the architectures, at least in the short term, are definitely going to be mixed as you go through the iteration, application by application.
Do you see these architectures still evolving significantly, or have we settled on how to go about this?
Oh, absolutely. I think there's a rapid pace of innovation and new things that are emerging. But there's also, I think, in a lot of ways, I think the risk is low. We've kind of matured enough where you can put compelling applications together. And again, to Neal's point, you have to think about like, what are the use cases? What are the applications that you want to support? What's the theory of operation of that system? What's going to be done locally? What's going to be done centrally? And ask yourself questions about kind of data ownership, data privacy, and how you go through that life cycle.
It makes sense. So Neal, given that, and given that there are, at least in the consumer space, emerging enormous ecosystems like Amazon is trying to do with Echo and Google with Google Home and so on. How heterogeneous do you think the architectures will end up being, say, 3 years from now? Is this all going to coalesce into a couple of key ecosystems that everybody subscribe to, or will there still be a Wild West out there?
Yeah, so I'm not going to go out on a limb and predict how long. I do think that it will evolve to a set of architectures that actually are maybe different per application or per type of, for example, machine learning or inference needed at the edge. But that it will consolidate, it will standardize and consolidate. It almost has to, right? Today it's very heterogeneous, but it's also very labor intensive in terms of building architectures in a network of systems, so you can deploy models to the edge, or so you can update over the air, or all those kind of things. That stuff, in order for it to be efficient long term, will have to standardize. How long? I guess I would say it probably won't be 3 years, but it will happen. Yeah.
And do you see the same sort of standardization emerging in the enterprise as in the home?
Yeah. Yes.
Any comments on this, Irina?
Well, it's interesting because I think, the home is different because like the consumer platforms are much more consolidated, right? You have your smartphone, you have the Alexas and the Google Homes. And that, in some ways, that's been going on both shorter and longer, right? Shorter and, longer in recent memory through the recent evolution, and it's been growing faster, right? But, it's, the industrial automation has been going on for many more years. It's just picking up the pace of innovation now. And so that standardization may take a little bit more time, I believe, in kind of the enterprise and the industrial sense.
I think it will be interesting to see how much control of the enterprise the individual providers are going to cede also. In the case of home, there's clearly this battle among Google and Amazon, and to some extent Apple. In the enterprise, I wonder how willing the individual enterprise providers will be to have a centralized ecosystem of the sort that is starting to emerge in the home.
Well, it'll take time, right? I mean, it always, so I grew up in the systems integration world pre-SAP, right? Before I got into inference and machine learning and what have you. And we built a lot of custom infrastructure for enterprises. But it took about 10 years, I would say, before there were lots of people on like 3 or 4 enterprise systems like SAP or Oracle, PeopleSoft or Dynamics or whatever, right? Yeah. And those infrastructures, pretty much everybody took one eventually, right? And did it take a while? Sure, it took a while, but there weren't 25 like there were when I started in the systems integration world.
Yeah,
right?
Makes sense.
Yeah, and I think part of it, the pace of innovation, the pace of getting to a new solution is just so much faster now. Right?
Yeah.
And, a lot of things are being done custom now, but a lot of things are going to SaaSify.
Absolutely.
Right? In this ecosystem where you no longer have to build your own perfect algorithm, somebody will build it for you and you'll tweak it to your, to your specific problem.
Yeah.
And so this ecosystem now, I think, just in the cusp of very rapid kind of, innovation and standardization.
Yeah. And I actually think that it won't ultimately end up being so much about models, because what she says is true, right? There will be some library of models that people will tweak. They'll add layers to neural networks or whatever. But the difficult part from my perspective of deploying these kind of systems is the monitoring the need to update those models
Yes.
out there at the edge. So it's almost the software infrastructure that you have to wrap around these inference systems to make them effective. And then also recognizing that unlike rules-based systems that we are familiar with today, they change. The data sets change. They drift. They get out of date. And you have to be able to update them. You have to be able to monitor them to know when things are going haywire, right? The inferences are becoming inaccurate or whatever. And then you have to be able to update them in place on the fly. And the infrastructures to do that, they need to be pretty standard, I would say.
I would just echo this like 100 times over, because I think, we've started, distributed systems are not new. You had things connected over the network, but these were policy-based systems where you had a very prescribed set of policies and you had a set of tools for managing those. But now the things you're deploying at the edge are evolving themselves and they're generating new data that's propagating decisions that you may not have full control over. But especially in regulated industries, if your car crashes, right, you need to be able to answer what it saw, why, which models, and what that life cycle looked like. Yeah. And even outside of regulation, that life cycle and understanding of data. And I think, from a data perspective, we're not used to managing it that way. That paradigm has been solved in a variety of different areas. Mm-hmm. It just hasn't been solved at the data layer. But now it's more about the data than the overall kind of policy constructs that are on top of it.
So I'm curious whether you think that this AI life cycle, as it were, of having to update these systems, do you think that will emerge in a managed way sooner in consumer electronics and the home, a la, updating the OS on your smartphone, or do you think it'll emerge in the enterprise first because the enterprise has so much more to lose in some sense? How is this going to go?
I'd say it's already emerging in the enterprise.
Yeah.
It's because they have to, right? They can't, it's not cost effective to do all these systems custom. And in fact, I would say the infrastructure that exists in the consumer market today was first in the enterprise.
Yeah, I would absolutely agree because, how many people update their router all the time or all their devices, right? But in an enterprise, you have the tools, the processes, the imperative to keep up to date, and you have a lot more to lose. So I think there's a lot of focus in the enterprise. I think figuring out how to tie the models to training data to versions in the field and how to do the whole model lifecycle and the data lifecycle is going to evolve pretty rapidly.
I would say it already is, right? Almost for sure. Most companies, and manufacturing applications better than I do, but since I come from mechanical engineering, manufacturing applications, those, let's just say devices out there, we're collecting data about the performance of machines on the shop floor or whatever. As an enterprise, it really is important for me to understand how good that stuff is and to be able to update it immediately. Mm-hmm. And whereas in the home, right, if Alexa's not listening properly and doesn't quite get what I say, well, who cares? You care, but you don't. There's nothing critical going on. I'm not saying that's a critical system. I'm losing millions of dollars if that machine isn't doing its job. Right?
So I'm curious, who do you figure ends up doing that AI lifecycle management? That is it some administrator within the enterprise itself? Is it the vendor of the ecosystem like the SAP, or is it the vendor of the models themselves, which are the various companies building the different ML pieces? How's that going to unfold, do you think?
Same way the enterprise systems unfolded. And today we're in the very early days, right? So you've got most enterprises that are actually, and there's just not that many, honestly, from my perspective, deploying models into the edge, whatever edge, however you want to define it, right? Are running they've mostly built their own infrastructures. Maybe they've used some components, and there's emerging components, and Kinetica is an example, but mostly they haven't. They've built their own infrastructures. They're deploying their own models that they hand built in those places, and now they're in the process of saying, okay, we got to make this. This has got to get more efficient. It's got to get better.
Seems very fragile.
Yeah. And so it'll evolve, right? It'll evolve the same way that the sort of enterprise systems evolved back in the 90s, I would say.
And when you look at systems, I like to look back at what happened in similar evolution with different systems. You look like data center management tools. There's so much overlap, right? If you were to draw it on a 2x2 matrix, everything is overlapping because people will come from an application side, an infrastructure side, et cetera. To your question, some of that will necessarily happen here because a lot of the vendors will offer a solution through their vantage point. And some of this is going to shake out. In our experience with enterprises, there are a few that kind of done them themselves and feel the pain. There are others that are still thinking, oh, I got to hire the data scientists, and I'm still in like the model thing.
Yeah.
And they can conceptually understand that this problem is coming.
Yeah.
They're just not yet feeling the pain as acutely as the ones that's kind of gone through it. And that's kind of the cycle that you have to.
Or you're starting to hear the guys who have gone through it come to conferences and give talks and say, and they put up these rules. Don't do this, this, and this, right?
Exactly.
And so the ones who haven't gone through it are like, okay, then I shouldn't do that. I got to go find somebody who at least has a reliable infrastructure.
Got it.
Right.
Yeah, this is going to be an interesting time to watch. Yeah. So switching gears somewhat, as we talk about ML and AI type processing in these enormous data centers, but also outside these enormous data centers, is it possible to do, for lack of a better expression, data center class AI or ML outside of the data center? Do we have enough horsepower in edge devices, and how far out on the edge, can you get near the sensor? Is it going to have to be some aggregated system higher than that? How much can be pushed to the edge, and how rapidly is that changing?
Okay. Go ahead.
Go ahead. Well, you probably have forgotten more than I'll ever learn at that particular time.
Probably not true. So let's see where to start on this one. Mobileye today can do inference at the edge on a chip extremely well. Right, extremely well. They're very good at it, and it's on a chip, right? They hand you a camera, it goes in your car, and the thing can detect signs and 100 other things right there, right? So it's possible to deploy things right out there, right at the sensor today, right? Question is that always the right thing to do? And the answer is probably not always. In a particular application of the mobilized cameras, sure, makes sense, right? In other kinds of applications in industrial settings, probably doesn't make sense. So there's a whole, as we said at the beginning, there's a hierarchy of applications that say, where should I do it? So to your question about industrial scale or sort of big data, the big data company inference, or even training at the edge, I would say it's an apples and oranges problem, right? You're not, the scope of what you're trying to do in an edge device is vastly different than what you're trying to do in a data center application like Google Search, for example, right?
Yeah, and we're seeing, I think it's like when you say data center class AI, what do you mean, right? Because there's kind of, even in the kind of the most basic form, you have the training and then you have the inference, and then you kind of have the continuous improvement and kind of retraining and tweaking of the models and analysis. I think in a lot of the kind of the initial iteration, people will start with training in the data center, then deploying at the edge. And there are a number of solutions that actually help you streamline your models for a smaller edge, for more embedded devices, where you can run those models in lighter weight form at this, at an embedded device level. Right? And then depending, if you're doing HD video processing, right, you need more processing power and you need a completely different edge than just doing a lightweight,
right.
A sense of
I'm sorry, I didn't interrupt.
And then sending that data for retraining, I think is an interesting question, because you kind of have to think about which data you need.
Yes.
Because part of it, you may just ask for the data that you thought was important, but there could be other that you didn't think they're important, that you didn't anticipate in your model. And that's kind of an interesting paradigm that people you don't know what you don't know.
Sure.
And figuring out how much do you send back to continue refining your models is going to be critical.
Yeah, absolutely. I mean, just as a data scientist, right, the difficult problem is which features actually matter. Yeah. And in those edge applications, you're actually making those choices ahead of when you know something, right, a lot of the time. In image processing, the problem's more or less, I would say, gotten a lot solved. But in other kinds of inference at the edge, not so much. Right.
Even with image processing, though, even if we imagine that much of the heavy lifting of training happens in data centers of various sorts, you made the point that, well, if you're doing HD video, maybe that requires heavier processing. But if you look even at home security cameras, it turns out that today's home security cameras and doorbell cameras and so on are all sending all of their HD video to the cloud for processing because, well, for whatever reason, but in any case, it is empirically the case that they're not doing the processing inside the camera. Yeah. Do you think that's going to change, or do you think that even that edge-ish processing of, is there somebody breaking into my house? Do you think that will continue to be transmitted up to the cloud?
I think it depends. I think a lot of it will be like cost benefit analysis for specific applications, and you'll have different type of cameras and different types of solutions, right? For your home security, you probably don't care, right? Or a lot of people, but for theft applications in like a nuclear facility, you probably care. You have a different set of requirements, right? For that.
Right, but even for home applications, one wants some level of security and recognition, and also one doesn't want to use up one's entire bandwidth to send data to the cloud. On the other hand, one doesn't want to have the accuracy loss necessarily of having a lousy security system at home because of an overly simplistic model inside the camera.
Right. Well, again, right, in the home security, let's just use home security for an example, right? So the goal there in the consumer space, I think, is that you got to get the cost low enough that people actually buy these things, right? So I don't want too much horsepower in that camera because it's a more expensive camera. Pretty soon the consumer won't buy it, right? And yet Mobileye is capable of putting inference in those cameras today, and not just them, others, NVIDIA and what have you, right? That's actually pretty good, right? In some cases, really good. And but now it's expensive, right? So the question is, how fast the costs go down for that more sophisticated hardware and infrastructure such that it becomes part of consumer devices, and now suddenly I don't have to have, I'm not having to send all that video even to a centralized server in my house.
Well, it's a funny thing, though. The camera becomes cheaper when you have removed that capability from the camera. On the other hand, you're spending for the bandwidth to send the data to the cloud, and you're paying that cloud fee as well. That's where the subscription fees are from these companies.
Or if I do it on a server in my house, I just have to send it over my local Wi-Fi, right?
Yeah.
Got it. And maybe that's how this evolves, that we end up with a different level of edge where one has a home server, although then one has to administer that home server. And so switching tacks yet again. So one of the things we had talked about as we were preparing for this is edge devices across space and time. That is the notion of having edge devices in different locations and also running at different times. How can we take advantage of that ensemble of different edge devices?
Wow. So here's a map making company, and I can tell you that particular question is really important to us because we have, when you're doing digital map making at the scale that we do it at, the question really is how do I detect when things are out of date and how do I get them up to date? So I have both time series problems, I have spatial problems. Where did it come from? Where did that image come from exactly? If I'm trying to extract the exact location of a doorway for my logistics customers, I need not just the image, or I need stereo image, which we don't actually usually have. Usually you have a single eye image and LiDAR to go with it, so I can say, hey, that's 5 meters off the road or whatever. And I need to know how old is that picture because has it changed or did that sign move or whatever, right? Yeah. So time and space all matter in this stuff.
It makes sense. All right. Well, so we're running out of time, but I'll give you the last word, Irina. So one of the things we didn't talk much about is 5G, and there's a lot of chatter about 5G and its importance for enabling more connected services. What role do you think 5G will play in the edge and in supercharging the edge? And so on?
Supercharging. So when you think about what 5G gives, it gives you more bandwidth, lower latency, ability to connect more devices. There's another thing that it also gives, is it gives service providers the footprint at the new 5G cell towers to offer edge computing capabilities. And so I think with 5G, undoubtedly, you'll connect more devices. Those devices will be able to speak to the tower much faster, so you can actually do more processing at the edge. But I think the edge computing device may actually shift from device edge to kind of the network edge. Of the service providers, and it's going to be an interesting dynamic between service providers and the cloud of how those roles evolve and how partnerships or competition will evolve over time.
Yeah, fantastic. Well, I think we're out of time, but I want to thank Neal and Irina for a lively conversation. We will hang out here for a while in case you want to ask additional questions or throw things at us or give us cookies. Thanks to both of you, and thanks to you for attending.
Thank you very much.
Thank you.